Okay. Assalamu alaikum. So we have done till here, and you guys have completed these graphs. So I'm going to make them quickly. So first you write the electronic configuration. So for carbon, it is 1s2, 2s2, 2p2. For aluminum, it is 1s2, 2s2, 2p6, 3s2, 3p1. For magnesium, it's 1s2, good, 2s2, 2p6, 3s2. For sodium, 1s2, 2s2, no, 2p6, with sodium 11, 3s, 2p6 and 3s1. Okay, so first the electron is going to remove from,
Yes.
in carbon 2p, actually from the valence or the outermost subshell, right? Okay, so the first electron is going to remove from 2p, and 2p has 2 electrons. The first 2 electrons are released with a very gradual, very slightly increase the second electron. Then the next electron is removed from,
Slightly.
yeah, a little greater increase because the subshell is changed. And then a big increase, which indicates the change in the shell. And over here, the first electron is removed from P. Then a little small increase from 3s. Then a big increase. And the 6 electrons are removed with the gradual increase. 4, 5, 6. And then a little big increase. And then, okay. Over here, the subshell is changing, right?
No.
Yep. But over here, the shell is changing. And then again, a huge increase to show the change in the shell. Then magnesium, the 2 electrons from 3s, then 2p, a shell is changed. Then a little increase because subshell is changed, and then a shell is changed. Then 3s, 1 electron, a big increase because the shell changes. Then 6 electrons with a very slight increase. Then a little big increase because of subshell, and then the huge increase with the due to the shell change. So we just join them. So this is how these curves are made. So from this, what you are observing whenever we are observing a huge jump, it is due to the change in shell. So it allows us to figure out the number of electrons present in the valence shell. So when we get the first bigger change in energy, it indicates that before that change, whatever the number of electrons which were removed are actually from the valence shell, and that same number is also the number of electrons present in the valence shell, and also the number of the group number as well. So let's have a look at from here. The question which comes related to this. So if you look over here, the first 7, okay, the first 7 ionization energies of an element A include joules per mole R. State the group of the periodic table to which A is most likely to belong. Explain your answer. First, for 2 marks. So 1 mark is for identification and 1 mark for the reasoning. Okay. So yes, if you see from first and second, there is almost a gap of 900,000, then almost 2,000, then almost 1,200, and then over here it's almost 14,000, something like that, or 15,000. So it means that these are the electrons which are removed from the outermost shell. So if you count it as you count it correct, so it's 5. So from that, what I'm going to mention over here, that it's from group 5 or 15, right? And it is because, yeah, there is a big jump, or there is a huge jump between the first, 5th, and 6th ionization energy. There is a big jump between 5th and 6th ionization energies. I hope it's understandable. Okay. Now, complete the electronic configuration of the element in period 2 that is in the same group as A. So see, period 2 means 2 shells, and same group means 5 electrons in. And what is the valence shell? The second shell is valence now, right? So in the second shell, I start from 1s2, and in the second shell, I'm going to put only 5 electrons. So first shell is already filled, it is 1s2. Then next we have 2s2. So in the second shell, I place 2 electrons. So 3 more are left, which are going to be placed in 2p. So it is going to be 2p3. Is this clear? Okay. Now, any confusion so far? Okay. Walaikum assalam. How are you, Moment? Why you are so late today? Why you are so late today? Okay. So we are done till here. Okay. Now have a look. The question related to this. If you see, I just discussed, so I'm just explaining you quickly. This is the energy needed to remove the first electron, then second, then third, then fourth, then fifth, then sixth. So see, if you see the differences between them, so from 5th to 6th, we are getting a very huge value. So it means that this is the, yeah, over here the shell is being changed. So it means from this and period, the electrons are removed from the first outermost shell. So how many energies we have? 5. So it means that the valence shell has 5 electrons, and if it has a 5 electron, then the group number must be 5 or 15. Now group 5 is also represented by 15 in the new periodic table. That is for A levels. Okay. Is this clear? Okay. Now, then the reason, and we are going to explain the same reason, that the big jump is between 5th and 6th ionization energy. Then the next part, complete the electronic configuration of the element in period 2. So from period 2, what we have concluded, it has 2 shells and in the same group as A. So the 5th group, it means it has a 5 electrons in its valence shell, and its valence shell is going to be second. So in the second shell, I need to just put 5 electrons in it. Is this clear? You just take this now. Yep. We'll proceed further. You are added in the group now. Okay. So the MCQs from this. Let's have a look at this. Yes, Nile and Momin, can you guys answer me this question? Five electrons in? Okay. Five electrons. No. So you will try, then he will try, then we will see. So what will be the answer then? Yes, Nile, what should be the answer? Why? Yep. Because the biggest difference is over here. So it means it's in the fifth group. So 5 electrons in valence shell. So group 5. Okay. Yes. Then how could it be C? Yes, moment. Yeah.
Chlorine.
But chlorine is in group 7. C. It is in group 5, right? So how many electrons it have in its valence shell? How many more it needs? 3. It needs 3 more to complete the valence. Yes. So chlorine with chlorine always make one bond. So in this, it is making 3 bonds. So it means it is getting the 3 electrons by sharing. So it is getting the total of 8 electrons in this. In this, it is getting the 9 electrons because the 4 electrons are being shared with it. So 5 plus 9, sorry, 5 plus 4 makes 9 electrons, which makes it wrong. 5 electrons are there and 2 electrons. So makes the 7 electrons in the valence shell. So the valence shell is not completed. And similarly, 5 plus 1 makes the 6 electrons in the outermost shell, which is again incomplete outermost shell. So C is the correct answer. Is this clear? Any confusion so far? Okay. So the next thing, I'll share the whole file again. Mass spectrometry. So basically, that is the last topic from the atomic structure. So what it is an analytical technique used to measure accurately two things which can be measured by it that is in our syllabus. So the first thing that it is going to measure accurately the mass of each isotope present in an element and its abundance. And when we get this data, that what we get to know, we got the mass and we got its abundance. So this data is then used for all of the isotopes, individual masses. So, so when we know that, for example, we get to know that how many number of isotopes are there and what is the mass of each isotope. Yeah, we will get the mass of each isotope individually and their abundances as well. So from this data, we used to calculate the AR of the compound, the relative atomic mass. AR of the element, of an element, not compound, my bad. Yes. I will discuss it in, with the bonding. Okay. Now, second thing that you measure it accurately, that is the mass of organic compounds. So, and that mass of organic compound from it actually help us. And there are further more things that can be analyzed from that data, which is further reduced, help us to reduce the structure of the compound. So this second part, that's what we will do when we will do the organic, after completing the organic. So right now, we are going to focus on how to calculate the relative atomic mass of an element through mass spectrometry data. Okay. So when we talk about mass spectrometer, so mass spectrometer is an instrument, or you can say device, in which sample of an element or compound is analyzed. Technique used. The technique is called mass spectrometry. So that is the diagram of mass spectrometer with its component. So we'll discuss how it will work first, then we will discuss later. things. Just 1 minute. Yep. On the basis of mass over charge ratio. Yep. Here I have separate the different masses. So momentum. See, that's the curve. In the curved region, they get separated. So actually what happens? Assalamu alaikum. Why you are so late? Okay. So what happens if you see this region? What we do, we just introduce the vaporized sample of element over here in this region. And there is a heated filament. What that heated filament do? That heated filament produces a high energy protons in this direction. So when the sample of atoms are there, so they all got a strike from these high energy electrons. So when the electrons hit them, they provide the energy to the valence electrons of these atoms, and as a result, they get ionized, the valence electrons get ejected, and they all turn into a positively charged ion. Is this clear? Okay. So that is what happened over here, that in this region, ionization of particles. Okay. So for example, if I talk about chlorine, let's suppose or assume we have a chlorine sample of a chlorine and we have introduced that chlorine sample over there. So here we have a chlorine, and there is this valence electron only. I'm just considering only one valence electron, although we all know that there are 7 valence electrons. So what happens from this? The electrons, the high energy electrons emit, and that strikes the atom. So as a result, what happens that this is, for example, a high energy electron which strikes over there, and as a result, it comes out, and the outermost electron as well, and the chlorine atom now become a positively charged ion. So that happens with all of the chlorine atoms. So let's assume we know how many isomers of isotopes of chlorine are. There are two, right? That's what we have studied in O levels as well. So there are two chlorine isotopes. So this is one kind of isotopes, and this is the other kind of isotopes. So what happens next? When the electrons gets removed from them, so all of these become positively charged, right? And what happens next? That these positively charged, actually, when the electrons are continuously striking from here, so they actually pushing those ions towards this region. Is this clear? So over here, these atoms now become ions, and all the electrons which comes out from these atoms, or the high energy electrons, those all gets attracted towards these electrodes, because all of these electrodes are positively charged and the electrons are negatively charged, and we are just have the positive ions over there, and these positive ions experiences the repulsion from these positive uh, electrodes, which accelerates them towards the towards the flight tube where there is a magnetic field. And in the influence of the magnetic field, they start separating from each other depending upon mass over charge ratio. The one which have a greater mass and a lesser charge, they are going to deflect less, and the one which have a greater mass to charge ratio are going to deflect less, which have a more are going to deflect more. So that's how they gets separated from each other in this flight tube. Is this clear? And now afterward, they're all going to strike over here. And when they strike over here, the ion detector detects all of these uh, detects due to different charge over, sorry, the deflection depends upon charge on mass of the subatomic particles. That's what we did initially, but this depend on mass over charge. So these are the two different things. So ion detector detect each particle due to its mass over charge ratio, and then it is able to further count how many numbers of them, so we will get the percentage abundance. Is this clear? Okay. Now, okay, one thing. Ions separate in this region, and again due to mass to charge ratio. And then on the computer, the recorder record all that data, and then on the computer we got a result, and that result is in the form of graph like this, where on the x-axis we have a mass over charge ratio value, And on the y-axis, sometimes we have just abundance, sometimes we have just ratio, and sometimes we have a percentage abundance. No, it is just for the understanding. There is no need to revise the diagram or remember the diagram. Okay, now let's talk about chlorine, because chlorine is the one which you all know that chlorine has how many isotopes? And what are those? Chlorine 37 and 35. Okay, so chlorine 35 and chlorine 37, right? So what happens to both of them in the initial state? They get bombarded, and when they get bombarded, they all both got the positive charge, right? Because one electron is being ejected. So if the one electron is being ejected, then what will be their mass to charge ratio? Sir, T. Okay. So what is the mass? Mass is 35. And what is the charge on it? +1. What is the mass? What is the charge? So the mass over charge ratio is going to be 35 for this isotope and 37. So it means that on the y-axis, which is actually a mass to charge ratio, is actually giving us the mass of each isotope. ये बात यहाँ तक clear है? इसमें कोई confusion? Okay. So, for example, okay, do you guys remember their percentage abundances? 75 of which one? Of 35. Very good. And the other one has 25. Okay. So if we have analyzed the chlorine, so what we are going to get, for example, it's 0, 10, 20, 30, 40. So it means 35 is supposedly over here. Then we have a 36, 37, 38, 39. And this is 35 and 37, right? So we are going to get two signals. One is at 35 and the other one is at 37. So if I scale it over here, this is 100%. This is this one. Now it's fine. So 25, 50, 75. So this is how we get the results. Okay. And from this results, we will calculate the relative atomic mass. So how we will calculate the relative atomic mass? So what we are going to do, we are going to take the isotopic mass times it with its abundance. Yeah. And then take the sum and take the other isotope and its percentage abundance. And then divide with 100. Yes. So we are going to get the result of 35.5. You can calculate it and check. Now I'm giving you the question. Okay. Okay. 1 minute. Is this clear? Nice. Okay. So this is the simplest question for you guys. They have given you the isotopes of iron and their percentages, and you need to calculate the AR. Hmm? Why you need a charge? There is isotopic masses are there. And the percentage, so you are going to do the same thing, each isotopic mass with its abundance. Which ratio? Yeah, that is, so instead of that, they exactly told you isotopic mass. We are taking it mass from the mass to charge ratio, but usually what we are assuming that this is the mass to charge ratio. And over here, it is +1. 55.7. Okay, Mariam, what is your answer?
Yeah.
It's the same. Three significant figures. If they haven't mentioned anything, but they mentioned over here, three significant figures. If they don't, then you have to always keep in mind three significant figures. Sometimes they mention that, yeah, it do, but then you just do, for example, if it comes in whole number like 55, so you would just write 55.0, three significant figures. And sometimes they do ask you to write the answer in five significant figures or six significant figures like that as well. Okay. Now, next, a trickier question. So this question is really easy. What you need to do to calculate the AR, that 54 times 5.84, then plus 56 times 91.68, then 57 times 2.17, and then just divide by 100, and what you guys are getting, 55.7. Yeah, but we do it with 100. That's fine. Okay. But if, for example, it's 99 point something, that's what you are getting. But for example, if instead of 99.5, when you add these percentages, if you are getting like 90 or 81, like if this is a big difference between 100 and that, then that value you are going to put in the denominator instead of 100. Okay. Yeah, do check. Okay. No. So the next question, a little high order question from this. This one. Normally, sometimes what they do, they don't going to give you like 80 or 70. There are two things. Either it is exactly 100 or just 99 point something. In that case, you need to just use 100. That is fine. But sometimes instead of percentages, they give you just the ratio, like 2 is to 3. So the sum of 2 is to 3 is 2 and 3 is 5. So if this is there is the ratio instead of percentage, then you are going to put the ratio in between in the denominator. Now how you will do this? Yes, Mariam. Yep. Mm. So there are two isotopes. For each one, how? If you are taking the one X, then what would be the other one? Both. Why? But you are sure that X plus 2 is actually that is the difference in their masses. So why you are making that difference in the percentages? No. See, okay, 1 minute. Let me explain. Moment, can you got it how to do? So okay, so the first thing, the bromine 79 has this isotopic mass, right? And the bromine 81 has this isotopic mass. Use the relative atomic masses of bromine that are okay, but how would you calculate the percentage of 79, for example, bromine 79? Okay, how you have calculated this? But your answer is correct. Okay, yeah, okay, continue. Mhm. Yeah, okay, that is fine. Okay, good. So the other way, what we know that in the sample, the percentage of bromine 79 and the sum of the percentage of bromine 81, what it will be 100, right, Momin? So as you just said, we can assume its percentage to be X. Then its percentage would be obviously 100 minus X. Or 1 minus X, then you will multiply it with the 100 later on. Is this understandable? Right? So now I can put both the values in the expression. So what I'm going to do, I know the AR, the relative atomic mass is 79.9, and they are asking you to figure out the percentage of both the isotopes, right? So 79.9 is equals to bromine 79 has the mass of 78.92 and its abundance is X, right? So I just multiplied them. And bromine 81 has the mass of 80.92 and its abundance is 100 minus X. And I'm going to divide it with the 100. So that is the initial expression we made. Is this clear, Moment? Yes, Mariam? Okay. So when I move the 100 to the left side, it will become 7990, right? Is equals to 78.92x plus 80.92 into 100 is 8092. And then plus minus makes it minus 80.92x. So what I do, I keep the simple numbers on one side, and the with the variable x, we are going to keep it on the other side. So what I can do that if I move 80.92 and 78.92 to the left, so it becomes 80.92x minus 78.92x is equals to 8092 minus 7990. So over here, what I'm getting 2x on the left side. Is it 2x, right? 80.92x minus 78.92. X is 51. So it means bromine 79 has a 51%. And on subtracting these two, what I'm getting? 108. 102. So X is equals to 102 over 2, which means 51%. So this is X, so it means it is 51%. And this is 100 minus X, so 100 minus 51 is 49%. So that is how we do this. Clear? Any confusion? Okay. So the next question. ओके ये आप लोगों का होमवर्क है, पिक्चर ले लें, ये आप लोग करके आएंगे। अगला वाला क्वेश्चन मैं भी दिखा रहा हूँ, उसका मुझे जल्दी से आंसर बता दे। So in the next class, we are going to do the past papers of the atomic structure because atomic structure is finished. 80.5, 18.5. Yep. Is what you are getting, moment. So the total percentage is 100. One isotope has a percentage of 56.36, that is copper. The other copper has a percentage of 25.14, and the percentage of gold is X. So if I subtract from 100 these two values, I will get the percentage of the gold. ये क्लियर है? ठीक है, तो वो क्वेश्चन आप लोगों का होमवर्क है। आप लोग उस क्वेश्चन को जो है ट्राई करेंगे। नेक्स्ट क्लास में हम फर्दर इसके क्वेश्चंस रिव्यू करेंगे। वो डॉक्यूमेंट आपको भेज दिया था इमदाद ने या नहीं? मैं भी फिर दोबारा ये, क्योंकि चैप्टर पूरा एंड हो गया तो पूरा चैप्टर